All right, so question 3 asks us to explain the similarities and differences between glycogenolysis and glycolysis in the muscle cells. It should be known that glycolysis is a 10-step process that breaks down glucose to obtain 2 ATP, 2 NADH pluses, and 2 pyruvates. And that process conceptually is usually broken down into 3 phases. Those phases are known as the energy investment phase, the energy generating phase, the energy investment phase, the splitting phase, and the energy generating phase. With the energy investment phase of glycolysis, 1 ATP is required and used to change glucose to glucose 6-phosphate, from which it is split, and the rest of the process of glycolysis occurs to redeem our ATP, pyruvates, and NADHs. That's what happens with glycolysis. In glycogenolysis, in the muscle cell, it is slightly different because we have to break down glycogen, which is the storage form of glucose, into glucose, and then we have to break that down into and then change that into glucose 6-phosphate. The difference between the two processes, glycolysis and glycogenolysis, lies mostly in that energy investment phase, as we do require an extra step to break down glycogen to glucose and then to glucose 6-phosphate. But overall, that breakdown to glucose 6-phosphate does not require the 1 ATP that it does in glycolysis. That being said, everything else about the breakdown from there of glycogen is the same as glycolysis is. It goes from glucose 6-phosphate and follows and splits, and then follows those 2 paths to get us our 2 pyruvates and our ATP and our NADH. The only difference at the end of those processes is that we have 1 more ATP that we gain from the glycogenolysis because it wasn't used at the beginning to obtain glucose 6-phosphate. So in glycolysis, that 1 ATP is used, and then glucose 6-phosphate is split and broken down. But in glycogenolysis, that 1 ATP is not used, so we end up with a grand total of 3 ATP, 2 NADH pluses, and 2 pyruvates.